Hello everybody. In this video we are going to solve the exercise 2 from the problem list of plotting functions. That is this exercise here. So the exercise starts with the definition of a double root. Remember that a root of a function where the function itself and also its derivative vanishes is called a double root. And the exercise asks to plot in a single figure the function f of x equals to the exponential of x minus 1 and also its derivative for the x domain minus 2, 2, both limits included. And then it says that we have to use a solid line with blue color for the function f of x and also a solid line with red color for the derivative. And in addition, we have to plot one more thing that is simply the x-axis. So the x-axis, remember that this is simply the values y equals to 0 using a black solid line. And after all, we have to ask three different questions. But let's go with the first part, which is plotting these three different vectors. So let's go to Matlab. We open a new script. We save this new script. Let's use the name problem2.m. And since this is a script, it's not a declaration of the function, we usually start using clear all to clear all the things that are in the workspace right now. Or if you want, you can use clear vars to clear only variables. Also close all the previous figures that were opened, and home if you want to start at the top of the command window. Then, since we have to plot three different vectors, let's go to construct first the vector of x that goes from the initial point -2 to the end point -2. And let's use a number of points, for instance, of 200. This is not asked by the problem, so we can use as many points as we want. And then let's construct this vector. We can use easily the function linspace from Matlab that needs the starting point, the end point, and the number of points. So this will construct a vector that goes from -2 to 2 with 200 points. So once we have this vector, we have to construct the vector of the function f of x, the derivative of f of x, and also the x-axis. So let's call first the function yf, which is the exponential of x minus 1. And also the derivative of x, which is the derivative of this function, is exponential of x minus 1. So remember in this step that since this is a vector, this f and this derivative of x are also vectors, because the built-in functions, in this case the exponential in Matlab, work in a natural way component by component in this vector. So the resulting operation is also a vector with the same size as the vector x. And finally, we also need the x-axis, right? Which corresponds to e equals to 0. We can use the 0 function in Matlab that constructs an array with the size that we want, full of zeros. In this case, we want a zeros of the same size of the vector x. So once we have these three vectors and the vector x, we can use the plot function to plot all of them in the same figure. So you can call the figure 1 in order to plot all the vectors in that figure. If you don't type this, then you will recover the figure 1 by default. Secondly, we call the plot function, which needs the x vector and the function f. And here, the argument that indicates the format of the line. So if we go to the statement again, we see that for the function f, we have to use a solid line with blue color. And for the derivative, a solid line with red color. And for the x-axis, a black solid line. So we need 3 solid lines with 3 different colors. So for the function f, we need a blue solid line. Then if we continue here doing arguments for the plot function, we can just write a new function to plot, which in this case is the derivative of x, in this case with red solid line, and also the axis with black solid line. So this sentence, we plot these 3 vectors on the same figure. Alternatively, remember that you can use, if we commented this, we can use the plot just for one function, in this case the function f, then type hold on and call again the same one, same instruction. For the derivative, call hold on again and plot the third one. In this case it's red, and in this case it's black. So both things, both ways work with the same result. So if you run this, you will see the 3 different lines that we are plotting. Remember also that you can format a little bit the plot using the legend function to label the lines that are in the plot. So the first that we have plotted is the function f. So this is f of x. And the second is the derivative of x with respect to x. Okay, we are not going to label the axis. So we run it again, and this is what we have. The function f of x in blue, the derivative of the function in red, and the x-axis, which is here basically to visualize better where the roots of this function and the derivative are. So if we go again to the problem statement, we have to answer 3 different questions. The first one is how many roots does the function have in that interval in -2, 2? So just visualizing the plot, we can say that the function f of x has only one root at the point x0, i0, you see? Then also the exercise asks how many roots does the derivative of the function have in that interval? The derivative of the function is the red line, and the red line has only one root at the same point x0, y0. So for the third question, that is, do they have something in common? The answer is yes, because both functions have the same root at the same point, which is exactly the definition of the double root. Remember that the root of a function where the function itself and also its derivative vanish is called a double root. And this is an example of double root. So as you can see, just a detail, what happens at the root of the function f of x is that the derivative, so the slope, becomes 0 when we approach the root. And as you may know, this has some consequences for the algorithm solving the root, finding the root of a nonlinear function. Okay, and this is the solution of this exercise. So thank you. That's all.